Hello class, in this video we're going to review when it is appropriate to solve a system of linear equations using either substitution or elimination and how to choose which one to use. Now, you would use either of these when graphing is not practical or when you need a more exact answer, because sometimes graphing is the solution would not be on a easily drawn graph, or it is fractional, so you are unable to easily tell what the solution is. Substitution and elimination do not have that problem. So, first things first, I use substitution when I can easily solve for a variable, meaning I can get it by itself, either x or y, or whatever it is in the equation. As long as I can get at least one equation, one variable by itself, I will use substitution. I will use elimination when I can get the variables aligned, meaning they are directly above each other. Okay, so in this example, there would be a total of 3. I could easily use elimination for this. However, this is one where I can use substitution because in this bottom equation I could easily get y by itself. So that's exactly what I'm going to do. So I'm going to add 3x to both sides, and that will give me y equals 3x plus 15. Now substitution is just that. I'm going to take this equation and I'm going to substitute it into the top equation. You cannot substitute into the equation that you used to solve in the first place. So I could not substitute back into the bottom equation. The answer would not make sense. So I'm going to plug this in for y, because I know what y equals. Y equals 3x plus 15. I'm going to use parentheses. I do this because it will help me avoid some errors along the way. So that gives me 2x plus 3, parentheses, 3x plus 15 equals 1. Okay, I just put this where I saw y in the top equation. That's all I've done. Now I'm going to distribute and solve for x. 3 times 3 is 9. 3 times 15 is 45. Now I'm going to combine like terms. 2x plus 9x is 11x. Now I'm going to solve for x. So I'm going to subtract 45 from both sides. So I get 11x equals negative 44. So divide by 11. And I find that x is negative 4. So, now what I'm going to do is I'm going to take this and plug it back into my original equation for x to tell me what y is. So, y equals 3 times x, which I know is negative 4 now, plus 15. 3 times negative 4 is negative 12. Negative 12 plus 15 is 3. So y equals 3. And I could write my answer as a coordinate pair of negative 4, 3. Now, you should always check your answer by plugging it back into the originals. Okay? In the interest of time, for this video, in order to try and keep it as short as possible, I'm going to avoid doing that. Okay, however, you should be able to do that relatively easily to confirm that you do get 1 in the top equation and 15 in the bottom. For my second example, okay, I'm going to take a look at this. I have 3x plus y equals 5 and 2x plus y equals 10. I could definitely use substitution here. However, everything lines up perfectly right now, and with elimination, I can either add straight down or subtract straight down. And if one of the variables cancels, I can do that easily and solve. Now, since the y's have the same number, and even though it's not there, technically it's a 1, and they both have the same sign, so I would need to subtract straight down. Some teachers say you must always use one particular technique, meaning add or subtract. I'm not like that. So I'm going to subtract straight down. 3 minus 2 is 1x. 1 minus 1 is 0y, so these would cancel. 5 minus 10 is negative 5. So 1x equals negative 5, okay, or just x equals negative 5. So that's what x is. Now I'm just going to plug it into either equation, whichever one I think looks easiest, and solve for y. So I'll pick the top one just because it's that. It is on top. So 3 times x, which is negative 5, plus y equals 5. So multiply this. Negative 15 plus y is 5. If I add 15 to both sides, I get y equals 20. So my solution here is negative 5, 20. Now, I could definitely check that very quickly in the bottom equation if I really wanted to. So 2 times negative 5 plus 20, does that give me 10? So that's negative 10 plus 20. Negative 10 plus 20 is 10, and that checks out. So I've solved this correctly. The last type of equation that I would use with elimination is a little bit more complicated. This is when numbers they may line up, okay, and I could easily make things line up. However, the numbers are different. So I have to make them the same. And it's entirely up to you what you would like to get rid of. I always like to use the first numbers, just because they're in front. So what I do is I cross multiply. So I'm going to multiply the bottom equation by the top equation's first number. Okay? And multiply the top by the bottom equation's first number. So I'm going to multiply the top by 3, because that's the first number, and I multiply the bottom by 4. And that will give me 4 times 3 is 12. 3 times 7 is 21. 3 times 10 is 30. Now I'll do the same thing for the bottom. 3 times 4 is 12. 2 times 4 is 8. 4 times negative 7 is negative 28. Now, if you notice, the numbers in front of x are the same. Now I'm ready to actually use elimination. However, since they have the same sign, I'm going to subtract straight down. So 12 minus 12 cancels. Negative 21 minus 8 is negative 29. 30 minus negative 28 is positive 58. So if I divide by negative 29, I find out that y is negative 2. So I know what y is. So now I'm going to take that back into either equation over here, whichever one I think looks easiest, and plug that in. I'm going to use the bottom one now, just because. It really does not matter. Y is negative 2. So, 3x, 2 times negative 2 is negative 4, equals negative 7. So, you know what? I'm going to rewrite this as 3x minus 4 equals negative 7. really doesn't matter. So I'm going to add 4 to both sides. I get 3x equals negative 3. So when I divide by 3, I get x equals negative 1. So my solution here is negative 1, negative 2, and I can double check that by plugging that back into the top equation now. Okay, that is our video reviewing using substitution or elimination. Okay, have a good night.